Hello, my name is Marcel Lewandowski. I'm with the University of Minnesota Water Resources Center, and I prepared my presentation with Hava, Blair, and Anna Cates, also at the University of Minnesota. Those of us working in the fields of natural resources and conservation intuitively understand that soil and water processes are tightly linked. But despite that understanding, we don't leverage soil health principles as much as we could to manage water resources. And there are two barriers to practical applications of soil management. There are two barriers to practical applications of soil management for water management. And first, we have only a weak understanding of the physical mechanisms by which soil properties add up to water resource impacts. And following from that, we don't know how to measure or statistically relate field properties and water resource properties. We can find studies that measure the impact of cover crops and tillage and other field practices on water movement and properties. And we can find studies that document different soil health measures in response to different field practices. But we have little idea of how the changes in dynamic soil properties might impact stream water quality. So why is it important to look at some of these issues? And why and how can we leverage soil health to manage water resources? A couple possibilities I'll toss out there. The first example relates to assessment. Can we use soil health measurements to identify the parts of the watershed that have the greatest potential to store water or to mitigate contaminant movement? And the second example relates to evaluation. Can we use soil health measurements to assess whether implemented practices are indeed having the functional benefits that we expect? It is conceivable that we could see those soil changes before we can measure changes in stream. In both cases, we need to do more to measure soil health and summarize soil properties across a watershed so we can compare soil to water outcomes. And what would you add to this list? Throughout this symposium, I'm hoping you'll be thinking about how this information could ultimately be applied. What are the mechanisms connecting soil and water? Starting on the right of this graphic, water resource managers are interested in how water is partitioned to the various pathways in the water cycle. And by that, I mean how it's partitioned between infiltration versus sheet flow versus channelized flow, transpiration, horizontal versus vertical flow through the soil, water detention in large lakes versus small puddles, and so on. So we're also interested in the rate of water movement or pausing along those pathways, and we're interested what's in the water. So that's the attributes of water. In the middle column is a list of soil processes that impact the attributes of water. Notice how these relate to the commonly stated functions of soil. So you can imagine how infiltration and hydraulic conductivity and water holding capacity, how all of those impact partitioning and the rate of water movement. And obviously chemical adsorption and desorption and all the myriad biological transformations impact what's in the water. And then on the left side are the attributes of soil that determine how soil functions. The structural characteristics and the biological characteristics. In structural, I mean everything from aggregate size and stability and pore structure to the size and type of organic particles. And biological characteristics, roots, microbes, macrofauna, the whole bit. Of course, the weather and soil chemistry and texture and the shape of the landscape and agronomic practices, all of these landscape and management factors impact the structural and biological characteristics of soil. That's the fundamental idea behind soil health and all these soil health measurements, efforts and management systems. The puzzle then is how do we quantify these mechanisms and relationships? And this is important because we want to predict the impact of our choices. For a given soil and landscape and climate, what management practices are going to give us the agronomic and water quality results that we want? And what are the trade-offs among the various soil functions and among the various water resource goals. We begin characterizing soil water mechanisms by measuring a variety of soil and water attributes and then trying to define the relationship between them. So for soil health measures, we're thinking of soil organic carbon, various physical measurements such as infiltration and aggregation, biological activity, and other biological measures. On the water quality side, we measure loads and concentrations of sediment, nutrients, other contaminants, pathogens, and flow volume, which, especially in Minnesota, is an important driver of water quality. Now, we'd like to think that as soil health improves, then water quality improves, as shown by the red line on this conceptual graph from Francisco Arriaga. But the shape of the relationship between soil health and water quality depends on which measurements you're comparing. For example, the blue line might represent the relationship between infiltration and phosphorus loads in water. As infiltration increases, perhaps watershed phosphorus levels improve to a point and then they plateau. Or conversely, soil health and water quality may have a negative relationship in the case of nitrate loads in drinking water. That is, nitrate loads could get worse as infiltration increases, especially on sandy soils with hydraulic conductivity. So you've got this increasing infiltration, which generally we consider that improved soil health, but it has a negative impact on water quality. Or consider some measures of biological activity. As activity increases, do nitrate loads get better at first, but then later they start to increase as nutrient cycling increase too much? One of the barriers to defining the shape of these relationships is the difference in scale of measurement of soil and water, in both spatial and temporal scale I'm talking about here. And like location, for example, soil we measure in the point, or we might at a point, we might measure multiple points and summarize that over a field. Water, on the other hand, we might be just measuring at an outlet of a large major watershed. We'll be measuring in stream, might be measuring edge of field. The frequency of soil measurements tend to be yearly, maybe a few times over the season. Water, on the other hand, after a precipitation event, we'd like to be measuring it hourly or daily. And then all of this, there's a different duration of measurements, depending on whether we're trying to understand seasonal variation or interannual variation. What this comes down to is that in-stream water measurements summarize what's happening across a watershed and is a sum of all of those activities across a watershed, whereas a soil sample represents processes at a much smaller spatial scale, but perhaps at a much longer temporal scale. Characterizing soil health across a watershed seems like it would require an impractical number of samples and summary analysis. So instead we do modeling, or we use land management as a proxy for the condition of the soil. So we're left with this scaling up problem. How does the water quality at the edge of the field and all the fields across a watershed add up to that water quality in the stream? The result of all these challenges is, here is the state of the science. So starting at the top of this graphic, with regard to the effect of field practices on water quality and flow, we've documented differences in how management systems impact water quality, at least at the edge of the fields. For example, we can say cover crops tend to reduce runoff or nutrient loss. However, the results of these studies are highly variable and inconsistent. So we have not defined how much of a watershed needs to be covered by a practice in order to reach water quality goals. We do have a pretty good idea how to identify critical source areas where practices should be targeted, but I'm not sure if we know where to site practices to most cost effectively impact flow. So moving to the left side of this image, what do we know about how field management impacts the dynamic soil properties? And again, researchers have documented differences in side-by-side comparisons of how management practices impact soil organic matter or aggregation or biological activity and so on. But these results are so highly variable that we can't predict the magnitude of change, and we can't interpret a measurement to give a manager guidance about how they should adjust their practices. And finally, it's rare that researchers have tried to make a connection between measures of soil organic matter or infiltration or biological activity and make a connection between those soil health measurements and downstream water quality. However, there has been some work in this area, and when it is done, it's generally by monitoring water at the edge of field or in subsurface drainage systems. Well, I'm excited to listen to and discuss the other presentations in this symposium where we'll get to dig into some of these issues. Arun Bawa and Francisco Arriaga are talking about various field practices and how to connect those to water quality measurements. Michelle Perez is reviewing models and how to use those models that can estimate water quality outcomes of field practices. Jess Gutnick and Anna Cates are linking soil health management to the adaptation to extreme weather. And Will Osterholtz and Kevin Fermanich and Anne-Marie Fortuna are all doing some really important field studies that are linking soil health at the edge of field to water quality or to edge of field water quality at several locations around the country. Margaret Kalsick and Gray Evenson, they're linking soil health and phosphorus loading in Western Lake Erie Basin, and Michael Kucera is also taking a modeling approach to looking at these topics, and Lee Fulmanson is linking or using remote sensing to link erosion to lake water quality. And there's a couple more presentations not on here to take a look at. So I am eager to hear your questions and your comments about this topic, and I really look forward to visiting with you on November 16th.